Okay, here is the first page of 3.1, Ready, Set, Go. This first part is really good. This could be all over the SAT. I really, really like these questions. When they give you statements like this, if A is bigger than B, then you should go ahead and choose an A and a B that makes that fact true, because you have some choice here, and then you can check through. You might have to adjust it if more than one is left and try another type, but this is going to be good. If, for example, 4 is bigger than 3, right? So because I put 4 is bigger than 3, then I'm going to have A is 4 and B is 3. Now, you could pick any numbers you want as long as that statement is true. So now think about what you know. 3A would be 12. This would be 12, and 3 times 3 is 9. This is bigger, and that should make sense to you because they're saying if you multiply both sides of something bigger than by something smaller, that something bigger is going to remain bigger. Okay, the next one here, B minus A would be 3 minus 4. That would be -1. And 4 minus 3 is +1. In this case, if you take the larger number, subtract the smaller number, you always get a positive number. This one will always give you a negative number. So your dummy questions here help you, but you could also use logic if you want to as well. Now here, remember, A is already bigger than B. If you add something that's the same to both of these, then A added with something will already be here. Oh. Okay. All right, next one. If X is bigger than 10, so like pick something, like what, 100? Let's pick 100. 100 square and 2 to 100. 2 to the 100 is really, really large. That is going to be bigger. The square root of 100 is 10. That's getting smaller. 100 squared is getting bigger. And then 100 squared and 100 cubed. Obviously, 100 cubed would be bigger than 100 squared. Okay, and on this guy, it says to pick something. Now, usually I would pick 1/2 here, but because of the square root, I'm going to pick 1/4. Okay, if I have 1/4 and 1/4 squared, 1/4 squared is 1/16, which is smaller. So 1/4 would be bigger. The square root of 1/4, square at the top, square at the bottom, is 1/2, and 1/4. 1/2 is bigger. And then 1/4 and 3/4. 3/4 would be bigger. Okay, that's the top. Like I said, those are really good questions. The second set here, when you classify functions based on a table, first thing I want you to look at is the functions you know. You know lines are really easy to see. They have a constant rate of change. They're arithmetic, plus, 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 minus, minus, minus. Whatever you see with a constant rate of change, the first difference is constant, and the other one you already know is exponential. Exponential is geometric in pattern, times 2, times 2, times 2, times 3, times 3, times 3, divide 2, divide 2, divide 2. So when you look at those, make sure you're looking at those first before you jump right into the differences. So here, what's happening? 3 to 6, I'm thinking +3, +6, +12. So that's not constant, but look, times 2, times 2, times 2. This guy is actually exponential, which hits home right now. So it's an exponential function. Repeated multiplication. They want to know how you know. Repeated multiply by 2. Here we have a +3, +3, +3, constant rate of change. This guy is linear, constant rate of change. The slope is 3, so constant rate of change. Here, what I have, +6, +12, no, +9, I can't math. +12, +15. But the second difference would be +3, +3, +3. So the second difference is constant. That means it's a degree 2 polynomial. It's a degree 2 polynomial or a quadratic. And how do I know that? Because the second difference is constant. What do I have here? Plus 2, plus 4, plus 8, plus 16. And then this guy has a times 2, times 2, times 2. So because of that, the times 2, times 2, times 2, this is also exponential. I think you guys are going to have a hard time with those exponentials. Repeat a multiplication on the second. After the first difference, maybe? I don't know how you'd say that. Okay, what happens on this guy? Well, I have a plus 7, plus 19, plus 37, plus 61. I'm only that quick because I'd already done this on the paper. Now the next one is a plus 12, plus 18, plus 24. And now for the third difference, I have a plus 6, plus 6. So the third difference is constant. That means it's a degree 3 polynomial. Or a cubic. That's the new guy. Okay, and I have markings all over this here. What do I have here? Plus 7, 15, 23, plus 31, plus 8, plus 8, plus 8. Second difference, constant. That means it's quadratic. So they want to know which one of these are not polynomials, which is funny because I think the answer are the two exponential ones, which are 10 and 13. However, the textbook said that the lines were not. I disagree with that. I think lines are polynomials. So we're going to say 10 and 13 because they are exponential, not polynomials. Okay, I'm going to stop this video here and I'll make the back page a video.